This is for year 11 methods. We're going to look at question 5 from exercise 5G. So on one set of axes, we want to sketch the original and the inverse function for this equation, this function. Now, be mindful, domain is, this is the domain. It's a restricted domain. So we don't want the whole graph of y equals x squared or f of x equals x squared. We want only half of it because we are going to, so if I call that y, I'm going to call that x. What's going to happen is I just want half of it. Okay, so half meaning literally I want half. Okay, so the graph looks something like this. Okay, so it's a regular parabola. It's going to look like that. Okay, and it includes that point. It includes zero because it's, you can see it's got a square bracket there. All right, when I draw the inverse, it's going to reflect on the line y equals x. So if I draw a line like this, it's going to reflect on this line. Okay, it's going to be a mirror for this line. Now, I probably don't have a good scale, so, but what's going to happen is, if I enlarge it a bit, if I enlarge the curve a bit, what's going to happen is, if I draw the y equals x line, you're going to have essentially two intersection points. Okay, so when you draw the inverse, what's going to look like is, if this line is the mirror, y equals x is the mirror, you're going to, well, we're going to ignore this part, so we don't want that part. We're going to reflect this part here, this part over here, here, and that part there, like that. Okay, so your graph, your inverse graph looks something like that. It'll be like a root graph. Now, so when you draw the inverse, it's going to look something like this. So you're going to draw, it's going to look something like this. Okay, because it's a exactly mirror reflection. So you're going to have intersection 0, and because I've drawn on a grid paper, I know what the intersection is. It's going to be 1, 1 over here. So I've exaggerated over here. So what's going to happen is, you're going to have the original looking like that, and your inverse looking like that. Okay, at 0 and 1, 1. Now to get the inverse equation, all you need to do is rearrange. So if I have f of x equals x squared, I swap the x and the y. So I'll go x equals y squared, and I make y the subject. So I square root both sides. So we get plus or minus root x. Now the inverse equation obviously has a shape of root x, positive root x. So f neg 1 x would equal positive root x. Okay. Now, how do I get the intersection between the inverse and the original? So this is the original, this is my inverse. So how to get the intersection? Well, it's the same intersection between f and x. Okay. So the intersection between f and x is just when you go f of x equals x. Okay. So you're trying to find the intersection between the original and the line y equals x, because the mirror is where, if they ever intersect, is where they'll intersect on the line itself. Okay, so rearrange. Oops, rearrange. So if I rearrange, we've got x squared equals x, because f of x equals x squared. And all you do now is you move the x's to one side and factorize. Take the common factor of x out and solve. So x equals 0 and x equals 1 using our factor law. Now, knowing that it's going to intersect on the line itself, now the line has equation y equals x. The x coordinate will be the same y coordinate. So that'll be 0, 0, and 1, 1, like that. So that'll be 0, 0 over here and 1, 1 over there. Okay, so hopefully that gives you an idea of how to get the intersection between the original and the inverse. Okay, it's always going to be intersect on the line y equals x, which means the x coordinate will always be the same as the y coordinate. Okay, and the quick and dirty way to do it is just go f intersects, find where it intersects with the line y equals x. because that's the same insertion point as F and F net.